Alright everybody, we are going over chapter 2 today in preparation for your incoming test. After you view this Edpuzzle, I would recommend that you take a look at section 2.5 a little bit more on your own. This chapter review that we're doing doesn't significantly cover that. That section is on piecewise functions, okay? So we're going to cover pretty much everything except we're not going to go into too much detail on piecewise functions. So you're going to want to study those on your own. We covered them a lot in class, so you should be able to fully understand them once you study it on your own, alright? Okay, so we're going through each problem that you were assigned, each problem. So these problems that you see on this PowerPoint are exactly the same as the problems that you are going to see on your paper, okay? Just let me make sure you can see it. You can see it. Alright, so remember that a function, let me pull out my marker here. Alright, so a function is a relation in which every element of the domain, remember, domain value is represented by x, is paired with one and only one element of the range, okay? So the domain means that, or whether a relation is a function or not, means that if you have to only have one y being mapped to by an x. X maps to one and only one element of the range, okay? So your domain, remember, is represented by x, and your range is represented by y. So one element of the domain maps to only one element of the range, okay? And remember, when we're determining whether something is a function or not, we can use something called the vertical line test. So the vertical line test, we just take a line and we just take the whole line and map it across to see if something is a function. So your first problem, can we determine whether this is a function or not? Well, let's do the vertical line test. So I look here and I see that these two points on my graph do not pass the vertical line test. Therefore, is this a function? This is not a function, okay? So vertical line test is one way in which we can determine if something is a function or not, all right? That's something you're going to need to know for your test. All right, how about this? So this chart is your next problem. So you have a Venn diagram here. Remember, this is a Venn diagram. And what makes a Venn diagram a function is if one x value maps to only one y value, because on the left side you have your x values, on the right side you have your y values. So what I see here is I see each x value mapping to only one y value. So that means that this is a function, okay? If I had, say, 5 here, and I had 3 mapping to 5 as well, this would not be a function. But I don't have that, so therefore this is a function. All right, how about this one? So now you have two different points here, okay? So 2, 5, 3, -1, and 1, 5. You have a set of ordered pairs here, and you have your x values first, of course, and then your y values last. So what we're looking for here is we're looking for x values that are the same to determine whether it's a function or not. If all the x values in this set of ordered pairs are different, it is a function. If they were the same, or if two of these x values were the same, it would not be a function. What I see here is the x values are all different x values, okay? So that means that this is a function, right? If I had another point that was 1, 2, this would not be a function because 1 and 1 are the same x value. But I don't have that, so this is a function. Alright, so now that we know how to identify what functions are, we can start evaluating different functions using different values of x. So when we evaluate functions, we are using an x value and plugging it in. Remember, f of x is the same thing as y, but key thing, x represents our input in a function. We went over this a little bit in class, but I wanted to rehash it. So x is your input, and then y is your output. Why do I say that? Okay, so I'm inputting x into my function, and then whatever I solve here will be my output, or my y. So that's what I'm doing here. So let's substitute in, first off, -2. F of -2 gives me 2 times the quantity, or 2 times -2 minus 10, and then f of -2 is equal to -4 minus 10, okay? So that gives us -14 for f of -2. All right? So that's what you would get if you solve for f of -2, all right? You just substitute in x, solve for f of x, or y is another way to put it. So f of 0 would be -10, and then f of 5 would be 0, just so that you can check over your answers. You just plug it in and solve. All right, now we're getting into everyone's favorite, the greatest integer function. So, greatest integer function, remember, greatest integer function is denoted by these braces here. And remember, with the greatest integer function, that means if I have a rational number, it rounds down to the next x value. So, the next greatest integer that it could possibly be. So, the integer less than or equal to x will be your greatest integer, okay? So for -1.2, my greatest integer would be -1, okay? So let's substitute in h of x, or h of -1.2 equals 2 times the greatest integer of -1.2. -1.2 rounds down to, I'm just going to do h of x here, rounds down to -1. Actually it does not, because remember, -1.2 is actually, -1 is actually higher than -1.2. So we round down. So rounding down would actually give us -2 for our greatest integer function, because it's less than or equal to x, -1.2. So this would actually be -4, okay? So -4. All right, let's do another one just to be safe. So h of x, let's substitute in 0.9. My greatest integer of 0.9 is 0, okay? So 2 times the greatest integer, of 0.9, h of x is equal to 2 times 0, which obviously is 0. All right, so you have -4, 0, and then your third one would end up being 8. So h of 9/2 is equal to 8. So that's what you're doing for those. You're just evaluating the function, okay? All right, so let's find the slope. Oops. So let's find the slope and the x and y intercepts, okay? So the slope. Remember, this is in standard form. So we're finding x and y intercepts and slope of this standard form equation. ax plus by equals c. All right, so in order to find the slope, we got to change it to slope-intercept form. Slope-intercept form, remember, is y equals mx plus b. So what we're going to do first, in order to turn this into slope-intercept form, is we are going to isolate the y. All right, the y has to be isolated on its own side. So in order to do that, my first step is to subtract 4x from both sides. So I'm subtracting 4x from both sides, and that'll give me -3y equals -4x minus 12. Okay? So that leaves us with y equals, because we're dividing by -3 now, so 4/3 x minus, or plus 4, because we're dividing by -3 for our next step. dividing everything by negative 3. All right, so we can determine my slope is 4 over 3. Now, how do I determine my x and y intercepts? Now I can still go back to my standard form equation. What I have to do in order to find my x and y intercepts is I have to remember your x-intercept is where your point is going to cross the x-axis. So it's going to be x, and your y is automatically going to be 0. So if you're finding the x-intercept, you just set y equal to 0. So 4x minus 0 equals negative 12. Okay? And that means 4x equals negative 12, x equals negative 3. So there is my x-intercept, negative 3. And my slope, now let's find my y-intercept. For my y-intercept, I set x equal to 0, okay? So 4 times 0 minus 3 times y, obviously, equals negative 12. All right, so negative 3y equals negative 12, y equals 4. And that's my y-intercept value. So that's how you find that, okay? You'll need to know that little segment for the test. So if you're confused on it, make sure you rewind the video. And this video will be available all night for your study benefit. All right, now we are actually graphing. So remember, when we're graphing, we usually like to have slope-intercept form to start us off. Slope-intercept form, y equals mx plus b. So what we're going to do here is, first off, we're going to change this to slope-intercept form. So that means we have to subtract 3x from both sides. Y equals negative 3x plus 7. Okay? So slope-intercept form, first off, let's identify my y-intercept. My y-intercept is 7. Let's put that up here. And then what does the slope say about my rise and run? It means I have a negative 3 over 1. So I'm going to go down 3, 1, 2, 3 over 1. Okay? And then when I have that, I can draw my line. I know my line looks pretty horrible, but it's the best I can do. All right. What's nice about the second one is that it's already in slope-intercept form. So we just have to plot our y-intercept first of all, which is b, negative 2. And then our slope tells us that our rise and run is up 1 over 1. Okay? And then we graph. That's pretty much what you have to do to graph those different ones. Okay? All right. Next one. Write the equation of the line in slope-intercept form. All right, so there's two things you need to identify with this particular problem. You need to identify the y-intercept, so b, and you need to identify the slope, which is m. Okay? So, because we're going to be writing it in the format y equals mx plus b. mx plus b. So, that means, first off, my y-intercept is wherever my line crosses on the y-axis, and my line crosses at 2. So that means my b is going to be 2. Okay? Y equals, what is my slope? Let's start at my point. Let's find 2 points that we can plot. There's a point up here. So that means we're going up 3 over 2. Up 3 over 2. So rise over run, my rise is 3, my run is 2. So that means my slope is 3 over 2x. Because remember, slope represents rise, or where it's going, up or down, over run. Okay? So rise over run, this is our equation. All right, now we need to figure out how to write the equation in slope-intercept form knowing a point and a slope. Point and slope. Sounds like point-slope form, right? What is my point-slope form equation? My point-slope form equation is y minus y1 equals m times x minus x1. All right? So point-slope form is how you solve these particular problems, okay? So what we're going to do here is we are going to substitute in to this problem. So y minus y1 equals m times x minus x1. So we have y minus 4 equals negative 1 over 2 times x minus 2. All right, so we solve it. So first off, we're going to distribute our 1/2 into our parentheses, okay? So y minus 4 equals negative 1 over 2x plus 1. And now to isolate the y, so we have it in slope-intercept form, we add 4 to both sides. Adding 4 to both sides gives us y equals negative 1/2 x plus 5. All right? So that is how you figure out that one. Negative 1/2 x plus 5 is your answer. All right, now we're getting into perpendicular lines. So things are a little bit different here. We have a point, but we are finding out the slope-intercept form equation for the line perpendicular to this one. So here's what we have to do to figure out this. First off, identify the slope in your perpendicular line. Your slope for the line that you're given is 3, but we are finding the slope-intercept form of the line that is perpendicular to that. For perpendicular lines, you will always have the opposite reciprocal of your line, okay? So the opposite reciprocal of m equals 3 is negative 1 over 3, okay? So that's your opposite reciprocal right there. All right, so now we are going to use our point slope form, y minus y1. Let's erase that real quick. I want to speed up here a little bit. So y minus y1, which my y1 for here is negative 2, so this actually is going to be a positive, because 2 negatives make a positive. So y plus 2 equals my slope of negative 1 over 3 times x minus 6. Okay? So here we go. Y plus 2, and then we distribute the 1/3, negative 1/3 x, plus 1/3 times negative 6. Negative 1/3 times negative 6 gives me a positive 2. Okay? A positive 2. So in order to finish this, I need to isolate my y. So subtracting 2 from both sides cancels out both 2's. So my answer is y equals negative 1/3 x. Okay? So that is how you find it when looking for a perpendicular line. All right. So now we have just 2 points. Where's my line here? We have just 2 points, and we're writing it in standard form this time. So what we need to do here is we need to identify a slope. Remember, to find slope with 2 points, we do y2 minus y1 over, let's make that 2 a little bit more easy to see, x2 minus x1. All right, so I have my y2 here, my y1 here, my x2, and my x1. So let's substitute in. M equals y2 is 0, and then my y1 is negative 6. Negative, a negative, negative makes a positive, so I'm going to do plus 6 over x2, 4 minus 1. So m equals 6 over 3, which makes m equal to 2. So here we go again. I have a slope and I have a point. I'm going to use this point. So I can use either one of these 2 points in my point slope form to find my equation, okay? So y minus y1 equals m. Well, actually, let's just substitute in now. So I'm going to use this equation. So y minus y1, or my y1, which would be 0, equals m, which is 2, times x minus 4. Alrighty. So 0 we don't have to worry about. So y equals, let's distribute, 2x minus 8. But remember, we're writing in standard form. What's standard form? ax plus by equals c. And a, b, and c are all going to be constants, okay? So that means we're going to have to take negative 2 over to the other side. And to do that, we subtract negative 2 from both sides. Negative 2x plus y equals negative 8. Negative 2x plus y equals negative 8 is the answer. If you got 2x minus y equals 8, that's also okay, because that is the exact same thing. All right, that's how you do that. Graph the following inequalities. Okay, so remember, graphing inequalities, we're doing the same thing as we are when you're graphing lines. So we start off by changing to slope-intercept form. 2y is less than negative x minus 6. Y is less than negative 1 over 2x minus 3. Okay? Y is less than negative 1 over 2x minus 3. So now we just have to graph our line. So our line starts off, let's first plot our y-intercept. Our y-intercept is at a negative 3. And then our rise and run tells us to go down 1 and over 2. Down 1 over 2 is right here. And remember, when you're graphing inequalities, you have to pay attention to the sign. It's going to be a dotted line because the line is not included in the solution. But if the line's not the solution, then what is? Anything less than the line. But in order to figure out what solution that is, we have to test this equation with a test point. So our test point is going to be 0, 0, the origin, okay? So let's test it. 0 plus 0 is less than negative 6. Is 0 less than negative 6? The answer is no. So that means the origin is not part of our solution set. So everything else on the other side of the line that doesn't include the origin is part of our solution. Okay? All right. So this one, the absolute value, is actually an absolute value equation. So for the absolute value equation, remember, every absolute value equation is in the format x minus h plus k. Oops. I almost put b because k and b are pretty similar to each other. K represents whether your absolute value line is going to be up or down along the y-axis. H represents what direction your vertex of your absolute value is going to be on the x-axis. Because remember, they all have the format that looks like this. We just have to figure out where the vertex is. So absolute value of x minus 4, where 4 is in the absolute value symbol. If you have a negative 4, remember your vertex for a negative value is still going to go to the right in the positive direction because in your formula you have a negative here. That indicates the opposite. So you're going to go in the opposite direction that is denoted here. So a negative 4, you're actually going to go in the direction of positive 4. Positive 4, and then you draw your V. Once you have the vertex right, it's very straightforward. Okay? Write an equation or inequality describing these graphs. So again, we have an absolute value equality. So this equality we can easily determine. First off, f of x equals the absolute value of x minus h plus k. Just to give you that idea. First off, let's find our k. Equals the absolute value of x minus, we're going to have an h, so I'm going to prepare for that. But what's our k? Our k is wherever it goes along the y-axis, and it's going down 1, 2, 3, 4, 5. 1, 2, 3, 4. It's going down negative 4. Okay? So if it's going down negative 4, negative 4 means my k is negative 4. Okay? Now I also notice that it is going to the left 2. So if it's going to the left 2, that means it technically is going to be a positive, because if it's going negative 2, it's going to be the opposite for my h. So that is how I obtain my absolute value inequality, okay? All right, next one. Write an equation or inequality describing these graphs. So we're determining the inequality now. The inequality. So first off, we got to pay attention to the fact that it's a dotted line. So that means we're going to have either greater than or less than. Not equal to, because it's a dotted line. So first off, we just got to figure out what the line is. So our line, our y-intercept is 3. Our y-intercept is 3. So we have 3 for our y-intercept. What is my slope? Well, if I look at my actual points here, I have another point here that's can be easily determined. So I'm going to go up 2 over 3. 2 over 3 x plus 3 y. So that's our line. That's our line, but remember, we have to figure out what inequality symbol we're going to put here. So in order to do that, we have to use another test point. Our test point, again, 0, 0. So 0 equals 2 over 3 times 0 plus 3. 0 equals 3. Okay, so what inequality symbol would make 0 and 3 true? It'd be the less than symbol. If 0 is less than 3, that means that makes our statement true. So the inequality symbol I'm going to put here is y is less than 2 over 3x plus 3. That is how you do that one, okay? All right, now we're actually getting into one piecewise function. One short, sweet, to the point piecewise function. So remember, with piecewise functions, you have a certain solution for different parts of the domain. And in this case, I have 2 different solutions. So f of x equals, let's do our little piecewise bracket here. So what do I notice about this first one? Anything less than 1 is equal to 3. My y is equal to 3, or my output is 3, if my input, which is x, so my output is y, my input, if my input is less than 1. Okay? All right, now let's figure out my second one. So for these, you're going to want to imagine the whole line. So I'm going to draw out the whole line just as a matter of example. Okay? And I actually graphed that very wrong. So let's erase that and start over. There we go. Okay. So this is what it looked like. Imagine if the line is completely drawn out. If my line is completely drawn out, what is my y-intercept? My y-intercept is -5. Okay? Then let's take a look at my slope. It goes up 3 over 1. Because here's my y-intercept. Up 3 over 1. Okay? So 3x. Is that right? Or did I do that wrong? I think I did that one incorrect. It's actually 2x. 2x. 2x minus 5. If x is, what is x? What are my values of the domain? My x values are greater than or equal to, greater than or equal to 1. Okay? I think I've noticed an issue I've made on this little graph here. I put this point here in the wrong place. So that's why this graph looks a little bit funky. But if I were to use the right graph, the one that's in your textbook, this is what your piecewise function would be, okay? So a little bit of confusion there, but hopefully it becomes resolved, okay? Last one. Find the distance and the midpoint. Remember, when you're finding distance for x, y, and z, you have your x1, your y1, your z1, your x2, your y2, and your z2, okay? we use the formula distance equals square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared, plus z2 minus z1, the quantity squared. Okay? So the reason why we square it, remember, is that distance can't be a negative. So we square it and then take the square root in order to account for that scenario. Okay? So let's substitute our values in. x2 is 3 minus x1, which is a negative 5. So we're going to put a plus 5 here because two negatives make a positive. The quantity squared, plus y2 is 6 and y1 is a negative 3. Again, two negatives make a positive, so it's going to be a plus 3. The quantity squared, plus our z2, which is negative 5, minus 7, the quantity squared. Okay? So, distance equals square root of 8 squared. 5 plus 3 is 8, and squaring that is 64. 6 plus 3 is 9, and if we square 9, it's 81. Negative 5 minus 7 is 12, negative 12. Squaring that gives us 144. And if you were to go through all of the different steps, you would come out with a solution of distance equals the square root of 289. Okay? So that's the distance, square root 289. Now midpoint, you're doing, so midpoint's a little bit different because to find the midpoint, you just have to add the values, the corresponding values together and divide it by 2. Okay? So, z2 plus z1 over 2. So let's do that. So my x2 is 3. My x1 is negative 5. 3 plus a negative 5 gives me a negative 2 over 2. Okay? Negative 2 over 2. And then my y2 and my y plus my y1, 6 plus a minus 3, gives me negative 3 over 2. Sorry, it's a positive 3 over 2. My mistake. And then my z2 plus my z1, so negative 5 plus 7 gives me, again, 2 over 2. So, my midpoint is negative 1, 3 over 2, and 2 over 2. Well, scratch that. 2 over 2 is equal to what? 2 over 2 is equal to 1. And that is all of the problems that you did, okay? So, hopefully that review was helpful to you. This whole video is going to be available all night if you need to backtrack, do some reviewing for your test. So, make sure you study for that test and that you do well.